Okay, so today we're going to pick up where we left off on Friday. We had started to look a little bit at solubility curves, um, and I'd asked you to do just questions 1 through 5 on this solubility curves worksheet 2. So we're going to start by going over those 5 questions, and for each question, I'll refer back to the solubility curve to show you where the answer comes from. Okay, so question 1 says, what substance has the greatest solubility at 55 degrees Celsius? So I'm just going to switch over to this solubility curve, and this is the one that you have. So when you're working on this assignment worksheet 2, or whatever it's called, solubility curves worksheet 2, make sure you use this solubility curve. They do vary slightly, and the little miniature ones that I've got in your notes are just a tiny bit different from this one. So if we all use this one to do the worksheet, then our answers will be more consistent. Okay, so the question was, what substance has the greatest solubility at 55 degrees? So we're just going to find 55 degrees, which is between these two lines, and we're just going to work our way up. Now this is going to be a little bit challenging because it doesn't all fit on the screen. Okay, so we're right in between these two lines, and we're just going to work our way up to the top. Okay, so now this particular graph cuts off here, but if you're to continue on, the line at the very, very top is going to be your most soluble. Okay, so that we can assume this line is going to extend outward and at some point intersect that 55-degree line. Okay, so it's actually the potassium iodide. It's whatever curve is at the top most part of your graph. Okay, so even though we can't find that intersection point on this particular curve, if we extrapolated, we would find an intersection point, and it would be much, much higher than either of these two lines. Okay, so the greatest solubility is potassium iodide, and that's the curve that's the highest on the graph. Which substance has the lowest solubility at 95 degrees Celsius? So let's go back to our curves, and let's find 95. So that's going to be in between here. And we're just going to simply find the line that's the lowest on the graph. So that would be the curve for sulfur dioxide. So we can see it's the lowest curve on the graph. So it has the lowest solubility. And we know that because it's the least number of grams able to dissolve in 100 grams of water. Okay, so our answer for 2 would be sulfur dioxide. Which substance shows the least change in solubility between 0 and 100 degrees Celsius? So when we're looking for the least change in solubility, we want to look for the curve that has the smallest slope, that doesn't show much change over time. So if you look, like for instance, ammonia changes from 90 grams can dissolve all the way down to, about, what is that, about 5 grams that can dissolve in 100 grams of water. So that's quite a large change over the 100-degree temperature change. However, if you look at this line here, notice it's almost horizontal. It has just the slightest bit of upward slope, and that is the sodium chloride line. So that just means at 0 degrees Celsius, about 36 grams can dissolve, and by the time you get to 100 grams or 100 degrees Celsius, only about 39 grams can dissolve. So it only changes by about 3 grams in the 100 degrees Celsius temperature change. So it has the smallest slope the least amount of change over that temperature range. So our answer for that one should be sodium chloride. Okay, question 4 says, which substances become less soluble as the temperature increases? So those, if we go to our graph, they're becoming less soluble as temperature increases. So those are going to be the ones that have a downward slope to them. You get less or fewer and fewer grams are able to dissolve as the temperature increases. So there's a few. Here's one here, HCl, hydrogen chloride or hydrochloric acid. And we've got this guy here, NH3, slopes down. And the only other one that slopes down on this particular graph is here, SO2, sulfur dioxide. So those would be the 3 that we would list for that one. And the last one I asked you to do was just deciding whether something was saturated, unsaturated, or supersaturated. So we're going to look at potassium chloride, and we're going to look at it a certain amount at each given temperature, and we're going to decide which one of these 3 it is. Okay, so let's start with 60 grams of potassium chloride at 70 degrees Celsius. So we need to find that exact point on the graph. So 60 grams, and the temperature is 70. So I'm going to go across this 60 gram line until I get to the 70 degrees Celsius, and my point is right there. Okay, so right at that point, I can see I'm looking at potassium chloride. Okay, so this is the potassium chloride curve. Well, I'm above the curve. So that means that I have more solute than can actually dissolve at that temperature. Whoops. Right? So if I'm above the curve, I have more than can possibly dissolve. So therefore, the solution would be supersaturated. Okay, the next point I'm going to look for is 25 grams at 30 degrees Celsius. So let's find that point. 25 grams would be here, and the temperature is 30 degrees Celsius, so that's right here. Okay, so I have this point here. Here's my curve. So I'm below the curve. That means I have less solute than a saturated solution can hold, right? So it could still hold more potassium chloride, up to about 10 grams more than I have could dissolve at this temperature. So if I'm below the curve, that means it's unsaturated. And finally, let's look at 50 grams at 80 degrees Celsius. Okay, so 50, I'm going to go across to 80. Now, this one I put saturated, but it does fall just a tiny, tiny bit below the curve. So I would accept slightly unsaturated or saturated just because it's so close. So more accurately, I guess you would say probably 51 grams at 80 degrees is the saturation point. But because it's so close, I put saturated. So either of those answers would be acceptable. Slightly unsaturated or saturated. Okay, so let's go on to looking at some calculations with solubility curves. So this can get a little bit tricky. Sometimes students find this difficult. Some questions are very straightforward, and others you have to do some you really need to understand what's going on in this graph, and you have to do a little bit of math to get to your answer. Okay, so the only thing that I kind of cut off from these notes is at the very bottom of the previous page. And it just talks about how this graph of solubility versus temperature is always based on being dissolved in 100 grams of water. So that's really important to remember. If a question gives you another amount of water, and we'll get to that really quickly, you have to set up a proportion like this and cross multiply in order to see if we're dealing with 50 grams of water, what's the equivalent fraction of over 100 grams of water. Okay, so we'll go over that more when we get to a question like that. So for these questions, these are the ones in your solubility notes. So this is the very last page of the solubility notes that we didn't cover in the last lesson. So that's where you should be at this point. For these questions here in the notes, I'm going to use this solubility curve graph here, just so I don't have to keep flipping back and forth. But it is slightly different from the one we just used to answer worksheet 2. It's not like hugely different, but your answers would vary a little bit. And the one we just used, I think, contains a few more curves than this one does. Okay, so just to make that clear, these answers are based on this graph, whereas worksheet 2 will be based on the enlarged graph that you have been given. Okay, so the first question is, what is the concentration of potassium nitrate at 44 degrees Celsius in a saturated solution? Okay, so we know we're dealing with potassium nitrate. That's this curve here. And we've got 44 degrees Celsius. Okay, so that's approximately here. And we know it's saturated. Okay, so if it's saturated, that means it's going to fall exactly on the curve. So we basically just have to work our way up from 44 till we hit the potassium nitrate curve. Okay, so we're about there, is about where we would fall, somewhere in there. Okay, so that is the point that we're looking for, and it's asking what's the concentration. Okay, so we would just then go over to the y-axis and see concentration is just a measure of how many grams can dissolve in water. Okay, so on this graph it's telling us that looks to be, I would say, and again there's a little bit of leeway here because this, you can't see every line on this graph, you're kind of eyeballing it. So I would say approximately 75 grams of potassium nitrate per, and it's always on this graph 100 grams of water, whoops, per 100 grams of water. Just erase that a little bit there. Okay, so those ones are pretty easy to do, right? You're just kind of finding the point and then landing on the curve and going over to the y-axis. Okay, so that's one possible type of question. Here's another question that I was referring to where we're given an amount of water that the graph does not depict. Okay, so the graph is showing us this is the solubility if we have this much water. Okay, if we don't have that much water, we need to adjust to 100 grams of water before we can read the graph. So to do that, it says 25 grams of potassium nitrate is dissolved in 50 grams of water. So before we even worry about the temperature or anything, let's make sure we can actually read this off the graph. So we've got 25 grams of potassium nitrate, and we've got 50 grams of water. Okay, so what is the equivalent fraction if we have 100 grams of water? Now, you could look at, so I'm just going to call this X. You could look at this and well, 25 over 50, that's half, so would be the same as 50 over 100. So this one would be pretty easy to do in your head. However, sometimes the numbers aren't that easy to deal with. So if you didn't know it off the top of your head, the strategy for solving for X is to cross multiply. Okay, so if I cross multiply, I'm going to get 2,500 equals 50x. And then if I divide by 50 on both sides, I would get x equals 50. Okay, and that would be 50 grams. So if am now going to read this chart, okay, I'm just going to get rid of the point we made before so we don't get confused. If I go to read this graph, I always have to read as if I'm dealing with 100 grams of water. Okay, so I would be finding this 50 gram point, because if I have 100 grams of water, I would need 50 grams of potassium nitrate in order to have this same concentration. And I have 30 degrees Celsius. So 50 and 30, my point is right there. Okay, I'm dealing with potassium nitrate, and it falls exactly on the curve for potassium nitrate. So it said, is this solution saturated? Yes, it certainly is saturated. Why? Well, 50 grams per 100 grams of water at 30 degrees Celsius is exactly on the solubility curve for potassium nitrate. Okay, so that's another type of question you could come across. This next one, a solution contains 5.2 grams of potassium nitrate dissolved in 10 grams of water at 40 degrees Celsius. What amount of potassium nitrate would be required to saturate this solution? Okay, so as soon as you see you're not dealing with 100 grams of water, your first step should be set up a proportion. Okay, so I have 5.2 grams in 10 grams of water. Okay, what would that be equal to if I'm dealing with 100 grams of water? Okay, so again, this one's pretty easy because to get from 10 to 100, you multiply by 10. So you would do the same thing here. But if you weren't sure, you can cross multiply. So you end up getting 520 equals 10 times x, so 10x. And then to solve for x, you divide by 10. I'm just not showing that step because I don't have a lot of room. So divide by 10 on both sides, and that would give you 52. So that means x is equal to 52 grams of potassium nitrate. Okay, so we'll just put 52 here so we don't forget. Now it's saying we've got 40 degrees Celsius. So let's find this point on our graph first. 52 grams and 40 degrees Celsius. So let me just get rid of our other point. Okay, so 52 would be about here, and 40, so I'm going to say about there. Okay, so that's the point we're dealing with. Now it's saying what amount of potassium nitrate would be required to saturate this solution. So here's our curve for potassium nitrate. So at 52 grams dissolved in 100 grams of water, we're currently unsaturated, right? We're below the curve. So it wants to know how many more grams could you add until you reach that saturation point. So we're here, and to be saturated at 40 degrees is where the curve intersects. So it's about there. Okay, so I would read that to be about 65. Okay, so I'm going to write saturated at 65 grams per 100 grams of water. Okay, so I simply need to go and find the difference. 65 minus 52 equals 13 grams required to saturate. Okay, but 13 grams is required if we were dealing with 100 grams of water. In the question, we're dealing with 10 grams of water. So we have to scale back down so that it works for the 10 grams of water that we actually have. Okay, so we need 13 grams if we had 100 grams of water. So how many grams would we need if we only have 10 grams of water? Okay, so you could, again, I'm sure, figure that one out in your head, but let's set up a proportion. So we have 13 grams if we had 100 grams of water. How many grams would we need if we have 10 grams of water? Okay, so again, you can cross multiply and solve for x. I'm kind of running out of room here. So that would make 130 equal to 100x. Divide by 100 on each side, and x would be 1.3. Okay, so 1.3 grams of KNO3 is required. Okay, so this is a fairly well, it's not complicated if you stop and think about it, but it requires a lot of steps to get to the answer. So always scale up to 100 to read the chart, and then you do have to scale back down if you're dealing with an amount in the end, right? For something like this, where you're asked like how many grams can be added, you will have to scale back down so that it makes sense given the amount that you started with. Okay, let's try a few more. This one says a solution contains 33 grams of potassium nitrate in 30 grams of water at 72 degrees Celsius. How much must this solution be cooled to saturate? And what that means is you could tell it's saturated if you cool it. If you have something at a higher temperature and you cool it, you can find the saturation point when crystals start to form in the solution. And normally we would do a lab like this, so you would actually see that process. So anyway, before you can read the chart, we have 30 grams of water, and we can't read the chart with 30 grams of water. So let's fix that. Okay, so let's set that equal to x over 100 grams of water. These spaces really should be larger. Okay, so if you cross multiply, again, so this one is one where it's not quite so easy to figure out what x should be, because 30 doesn't go evenly into 100. So this would become 3,300 equals 30x. And if you divide both sides by 30, x would equal 110 grams. Okay, so that's what we're going to be dealing with when we look at the chart. Okay, so 110 grams is the equivalent amount if we had 100 grams of water. So let's find that point, and we're looking for 72 degrees Celsius, and this is still potassium nitrate. Okay, so I'm just gonna get rid of our other 2 points. Okay, so we have 110, and 72. So I'm going to go across. 72 would be about here. Whoops. So about there somewhere. Okay, so that's what we're dealing with. And the question says, how much must the solution be cooled to saturate the solution? Okay, so if we're here, at this temperature, the saturation point is way up here, okay? But if we're sticking with 110 grams, where is the saturation point if you have 110 grams? What's the temperature at which 110 grams of potassium nitrate would be considered saturated in 100 grams of water? Well, that point is where the curve hits at 110, which is about here. Okay, so that temperature, excuse me, is, if you go down, it's about 59 degrees Celsius. Okay, so we're at 72, and to be saturated, it's 59 degrees. So there, what you would do is say, okay, it's saturated at 59 degrees Celsius. 72 minus 59 is a difference of 13 degrees Celsius. Okay, so why in this question am I not scaling back down? Okay, so in this previous question, I scaled up to be out of 100 grams. I got a number of grams based on the 100 grams of water, and then I scaled back down so that it was based out on 10 grams of water. Here I also had to scale up to read the graph, but I didn't scale back down. The reason being is with temperature, you can't scale back down, right? This temperature is based on the ratio, right, of amount of grams of solute in amount of grams of water. So in questions where your answer is measured in temperature, like degrees Celsius, there's no need to scale back down. This 13 degrees Celsius works for 110 grams in 100 grams of water, and it also works for 33 grams in 30 grams of water. Okay, 2 more to go, and then you can try some on your own. What temperature is needed to dissolve 40 grams of ammonia in 100 grams of water? Okay, so finally one that's a little bit less involved. So all you need to do for this one is find 40 grams and find the curve, and then read down to the temperature. Okay, so let's get rid of our other points so we don't get confused. Okay, so 40 grams, and I'm looking for the NH3 curve. And notice this one is in 100 grams of water, so I don't have to do any scaling here. So if I go across, my NH3 curve is this one here. Okay, so if I go across on the 40 line, it hits the curve right there. Okay, so then I simply go down to the x-axis and read what temperature that is. I'm going to say that's about 37 degrees Celsius. So I'm going to use this just because some of you might say that's 36 and some might say it's 38. So somewhere right around there. And the last one, what is the solubility of potassium chlorate at 90 degrees Celsius? Okay, so again, this one is a little bit more straightforward, no math involved. So we have potassium chlorate, which would be this guy here. Okay, and it just wants to know, it'll either say what's the solubility or what's the concentration. Either one is looking for the same thing. How many grams of solute can be dissolved in 100 grams of water? Okay, so we've got 90 degrees. Okay, and we're just going to go up to the potassium chlorate curve. So we're just right there. Okay, so just above the 50 gram mark. So if you go over, I would say that's 51 grams. So I would write that as I'm going to use this again, just because I'm just eyeballing that. 51 grams of potassium, oh, it's not potassium nitrate, it's potassium chlorate this time. Is dissolved for every 100 grams of water. Okay, so again, just notice you'll either see this word solubility, or in question 1, we were doing the same thing, but it said concentration. So either one, you're just looking for how many grams can be dissolved in 100 grams of water. Okay, so you guys can try carrying on with those questions on worksheet 2. Some are straightforward, some are more detailed and involved, like these guys here. I'll attach the answer key today as well, just so that you can kind of check as you go.